Welcome to the DIY Honda Garage channel. The Honda CR-V models from 2017 to 2022 can exhibit various diagnostic trouble codes, DTCs, with DTC P16E6 specifically indicating a malfunction in the transmission range switch start switch circuit. This error can arise from several issues, including wiring faults or problems with the transmission range switch itself. The transmission range switch is crucial as it determines the current gear of the vehicle and allows the engine to start when in the correct gears, namely park, P, or neutral, N. It is typically found on the transmission assembly, making it a component that is directly tied to vehicle operation. Diagnosing this code involves detailed steps, including utilizing specialized diagnostic tools such as the Honda Diagnostic System, HDS, to clear DTCs and measure continuity. Understanding the context and components related to this trouble code is vital for accurate repairs. DTC P16E6 points to an issue with the transmission range switch start switch circuit. The transmission range switch is a pivotal component located on the transmission assembly, playing an essential role in determining the current operational gear of the vehicle. This switch monitors whether the transmission is in the park or neutral position and signals accordingly to the Powertrain Control Module, PCM. The start function is critical for vehicle ignition, ensuring the engine can only start when in the proper gear to prevent accidents. A malfunction can lead to significant drivability issues, as the vehicle may fail to start or may inadvertently engage other gears. Being aware of the exact location and function of components is important for troubleshooting the system effectively. The potential causes of DTC P16E6 can be summarized into a few key areas. The first cause is a short in the ATPST or ATPST wire. ATPST stands for Automatic Transmission Park Start Torque, which is critical for startup detection. A short circuit can disrupt transmission signals to the PCM. Secondly, poor connections or loose terminals at either the transmission range switch or the PCM can lead to intermittent issues that trigger this DTC. It's vital to inspect these connectors for corrosion and damage. Lastly, the transmission range switch itself may be functioning improperly due to wear or internal failure, requiring replacement. Identifying these issues early can prevent more significant problems down the line. When DTC P16E6 is present, several symptoms may manifest, indicating trouble with the transmission range switch circuit. A primary symptom is that the engine may not start at all, often due to incorrect signaling from the transmission range switch. This may cause confusion when trying to start the vehicle, leading the driver to think there is a broader electrical issue. Additionally, inconsistent ear shifting may occur where the vehicle may unexpectedly shift gears or fail to recognize the current gear, impacting driving stability. Finally, dashboard warning lights may illuminate, alerting the driver to a fault within the starting or transmission systems. Recognizing these symptoms is crucial for initiating timely diagnostics. The first troubleshooting step for addressing DTC P16E6 involves initial verification procedures. Begin by turning the vehicle ignition to the on position. This engages the vehicle electronic systems, allowing for diagnostics. Next, use the Honda Diagnostic System, HDS, to clear any stored DTCs from the system. Clearing the code is essential to ensure any future observations are from a fresh state. After clearing, shift the transmission into a gear other than park, P or neutral, N, and maintain this position for at least 5 seconds. This action simulates an operational condition that may help in identifying pending or confirmed DTCs. Following these steps prepares you for further diagnostic checks based on the vehicle's responses. In the second troubleshooting step for DTC P16E6, the vehicle must first be turned to the off-lock mode to ensure safety during diagnostics. Following this, disconnect the transmission range switch 10P connector to inspect for electrical continuity. With the connector removed, you will check for continuity using a multimeter between specific test points. Test point 1 refers to terminal number 7 of the transmission range switch 10P connector, while test point 2 should be connected to body ground. If continuity exists, this suggests that the circuit is intact and the next step should be followed. Conversely, if continuity is absent, further investigation is warranted into possible cable faults. The third troubleshooting step involves another continuity test, focusing specifically on the transmission range switch itself. First, shift the transmission to a position other than park, P, or neutral. The vehicle remains in the off-lock mode with the 10P connector disconnected. You'll check for continuity between test points, where test point 1 is now the male terminal number 7, and test point 2 is the male terminal number 4, one on the transmission range switch connector. If continuity is confirmed, this indicates that the switch's internal contacts are functioning as expected. However, if continuity is not present, it usually requires replacing the transmission range switch due to failure. Additionally, always check for poor connections or loose terminals at both the switch and the PCM. In the fourth troubleshooting step, you will assess the potential for a short in the ATPST/ATPST line. First, jump the SCS or Service Check Signal line using the HDS, allowing the system to enter a diagnostic state for more than 1 minute. After this, disconnect the PCM connector E, specifically the 80-pin connector, to allow for safe testing. Again, conduct a continuity test between test point 1, which is PCM connector E terminal number 67, and test point 2, which is to body ground. If continuity is present here, it indicates a short has occurred within the wire between the PCM and the transmission range switch, necessitating repairs. If there's no continuity, it suggests the wire is intact and further inspection into other components, or possibly a known good PCM, may be required. After completing the necessary repairs for DTC P16E6, it's vital to verify that those repairs were successful. Begin by reassembling any components that were removed during the diagnostic process, ensuring all connectors are securely reattached. Subsequently, clear any DTCs that may currently reside in the vehicle's computer using the Honda Diagnostic System, HDS. This step resets any malfunction indicators, paving the way for subsequent operational tests. After clearing, perform a thorough test drive to assess whether the vehicle operates correctly without returning the previous fault. Successful verification ensures that the issue has been fully resolved, restoring the vehicle's functionality. Preventive maintenance is key to avoiding recurring issues with DTC P16E6 and maintaining overall vehicle reliability. Regular inspections of the connections associated with the transmission range switch and related wiring can prevent future failures. Look for signs of corrosion, fraying, or loose terminals that may lead to intermittent circuit issues. Additionally, servicing the transmission range switch periodically can help maintain its functionality, ensuring it remains responsive to gear changes. Keeping a clean and dust-free environment around these components also minimizes the risk of unexpected faults. Proactive maintenance extends the lifespan of these critical components and enhances driving safety. In conclusion, DTC P16E6 is a diagnostic trouble code that signifies a malfunction within the transmission range switch start switch circuit of Honda CR-V models from 2017 to 2022. This code highlights the importance of the transmission range switch in vehicle operation, especially concerning safe engine startup. Problems can arise from wiring issues, poor connections, or switch failures. Comprehensive troubleshooting steps, including continuity checks and system verification, play a crucial role in identifying and resolving the issue. Adopting proactive maintenance practices ensures the vehicle runs smoothly, permitting safer operation and helping drivers avoid future complications. Please like and subscribe to the channel. See you next time.